Gina Bria from the Hydration Foundation, and I would like to introduce Chad Wall. Chad, the Hydration Foundation is coming to you. You may wonder why, but we are, of course, very interested in hydration here at the Hydration Summit. And one of the questions that comes to me is, why are you so interested in agriculture if you're a hydration foundation? And when I share with them that 70% of the world's water use goes to agriculture, and that makes it our business.
Right.
A very important part of what we do is water use reduction, and then our goal to help hydrate people through healthy plants, vegetables, and fruits also makes agriculture our business, because getting those healthy plants, veggies, crops, fruits, all of that, nuts, all the things that the world, the creation grows for us on farms is a really important part of what we want to be doing. And we're coming to you because it's becoming apparent that you are becoming a leading expert on how hydration and irrigation practices are one of the new ways, new forms of thinking on accelerating soil health much more quickly. There's a lot of conversations around how to restore soils, but using the hydration irrigation already in place to accelerate it is a new topic, and we like to introduce that. And we are very lucky to have found you, and wondered if you would share with us how you became experienced in using hydration or water to accelerate farm and land and soil recovery, plant health, etc., etc., etc.
Okay. Well, Gina, going back to my childhood growing up here in Texas on farms that were mostly not irrigated at that point in time, nobody really knew how to utilize irrigation to really grow cotton effectively, which is what our region is primarily grown historically, is cotton. I witnessed that, the differences between good years and bad years were often the rainfall. Even as a child, I just understood what my father's take on rain was, and how to utilize water, and how that was always the difference. And oddly enough, 40 some years later, if you go to any group of people, particularly in agriculture, and you ask them what their greatest limiting factor is, it's always water. And so we can't change that in every circumstance, but we have discovered that we can actually have a huge impact on it. And I think that as we continue to explore and research the things that we are exploring, we're going to determine that we actually can have a greater impact than we even thought. And so the resiliency of the water that's in the soil ecosystem is actually very dependent on the way that water gets applied, and the time in which it gets applied, and then the soil's ability to hold on to that water and release it back to the plants or to the microbes when they are actually in need of it. So the bigger story there is, it's not so much the amount of water that you're getting, but the timing of the water that you get, and then, and obviously how that water is being applied when it comes to the type of water that we're actually applying to the fields, and seeing the tremendous results that we are from structuring that water.
Yes, that's the conversation I want to link us with, because I understand you're using structuring devices just as a complement or an addition to irrigation systems already in place. Talk a little bit about that.
That's correct. So, along that same conversation of my maturing and beginning to think about things that I had heard from my dad or from my granddad, and really thinking about those things, one of the unanswered questions was, well, why does rainwater produce so much greater results than irrigation water? And most everybody who's watered anything, has witnessed the same type of experience where, a little bit of rainwater will do much more than, sometimes 2 or 3 times as much irrigation water, whether that's watering your yard or watering field crops, either one. And so that kind of began my questioning of, well, what's the difference between water? I mean, from my basic chemistry, and I didn't study chemistry in college. I did study agronomy and agriculture, and with a master's degree in agriculture, I still had no idea why water functioned so differently in different circumstances. And that was always very curious to me. So I started exploring all the water, actually for application of pesticides and different things. And we validated a lot of neat things there, but I also came to understand that there were a lot of things about RO water that I didn't like, because I didn't like the waste. And I didn't like having to find something to do with the discarded water that, was rejected from the system. And so we were pumping a lot of water only to reject sometimes as much as 50 to 60% of that water. And in some circumstances, even more. That just didn't make sense, that something so precious as water would be unutilized because of the way that we were refining it or seemingly making it better. And so as I continued to pursue that, I came upon structured water and started reading about what structured water was capable of, and started connecting dots and, trying to gather all the information and research, which was very little research that was being validated scientifically, so there was a lot of stuff to wade through to get to the understanding of, wow, I think that when you structure water or you put it back to the way that it was intended to be, it functions like rainwater. And that's what we're seeing on a field level basis now, is that we're producing, hard to quantify exactly, but we're producing very good results, where we are reducing the amount of water by as much as 30 to 40% and having better crop response.
Oh my gosh.
And so it's significant.
I want to ask you about, I know you've identified 4 specific areas, but just for our audience who may be listening, I want to recognize that the water that is typically used to irrigate is not structured. It's been interfered with in some way, either through water treatment processes or through piping, that breaks up the natural form that the molecule is found in. So really what you're looking at is we're calling it structured water, but what we're really looking to do is return water to its natural efficient state. And I love hearing what results you're having, the top 4 results you're having with water that's been reorganized and returned to its natural state using some of these devices.
Correct.
Mm-hmm.
Yeah, so to build upon what Dr. Pollack and some others have witnessed in their laboratories, there's an energetic property of the water that has everything to do with the way that all of the things that are in the solution relate to each other. And the fact that they're there doesn't necessarily mean that they relate to each other. I'm speaking molecularly. All of those elements don't relate to each other the same in all circumstances just because it's there. And so when we adulterate that water from its natural form, we compress it and we pump it and we force it down, long lengths of pipe that are applying friction to it. And it's all of those energetic properties and other things that are impacting that water that force those bonds together to create different clusters of molecules based on all of the things that are dissolved in that water. And so,
it's like that interferes with our notion, the way we treat water now, industrial treated water, that it actually, the original principle of water is that it's the universal solvent. And it seems like that quality of water's ability to dissolve both contamination and nutrients to allow them to actually be bioavailable is what's the missing link in accelerating regenerative agriculture. That if we look to the water we're already using, we're going to very quickly change how we can recover the land more with more efficiency more quickly. And that's why the Hydration Foundation is really involved in these agriculture projects. So tell me if it's true. I'm just going to do my little list of 4 here. Have you found from your field experience now, Chad, that something like a 30% reduction in water use because it's much more efficient?
That's correct.
Wow.
Yeah.
That's a big number. And in some cases, all the way up to 50%, depending on the circumstances.
That's correct. And those measurements were actually taken with soil monitoring probes that were scheduling the irrigation interval. So that's not just a feeling about how much water has been applied. That's an actual assessment of what has historically been provided to keep the saturation in the soil at that level compared to how much water that was structured needed to be required. And again, this is same field, same water source, same distribution system. The only change was that we added devices to structure that water. And what we measured in the soil was that 30% plus was actually required reduced water amount to produce the same level of saturation in the soil.
That's good news. And in addition, a reduction in pesticide and fertilizer use. Is that true too?
Correct. Yes. And so some of the studies that we've seen, and we'll be conducting more studies this year, are indicating that just the availability of the nutrients, whether they're soil applied or applied in the water solution being fertigated on, the response, and we're validating that with SAP analysis so that we actually know what the plant is metabolizing. Again, we're not guessing.
Mm-hmm.
The best technology that we have available to actually validate that the plant's response is different. And so, a lot of the science that has struggled to validate the character of structured water compared to what would be deemed unstructured has been difficult in a lab, because in a lab, it's always a very sterile, non-living system, because that's the way that science is set up. It doesn't take into account biology. But when you enter the biology into the equation, then everything changes. And so we've had to really be, creative in our pursuit of taking measurements from, soil available nutrients to actual nutrients available in the plant, and what the plant's actually showing us that it's metabolizing to actually show that, yeah, this is making a difference. So whether we can validate it with a chemistry experiment or not, the plants in the soils don't lie about.
They are wonderful evidence. And I've also heard that there is a higher yield in the crops. The plant health goes up, the crop yield, even in conditions that are challenging, where a crop may have been lost in the past.
That's correct. And we can't validate all of that, Gina, but we can draw some theories in regard to if the water use efficiency is improved that much, then we're hydrating the biology in the soil a lot better. We're hydrating the plant a lot better. The plant likely has a much greater efficiency at transpiration and the other things that the plant is doing to help itself in those stressful conditions. And so the greater effect that we have on limiting the stresses, the better the crop response.
So the 4 key areas are the water reduction and efficiency, that we have elimination or reduction of pesticides and fertilizers, while at the same time improving plant health and crop yield, and building soil microbial communities that restore soil health. That's an amazing list. And this is all within a year. We can accelerate all of those stories going on for. This is just such profound and important news. We're very excited to share your expertise and to hear from you about these new ways to join the regenerative agriculture movement to recover our lands at much faster rates than we really dreamed. And of course, we know that soil is one of the most improving soil is one of the most efficient forms of restoring our aquifers. Wow, the more topsoil we have, the more it holds the rain, the more that's able to drip back into the aquifer. No, I don't even know anyone who's talking about. They're just worried about it. They're not talking about strategies. Right. So right. Farming and farms turn out to be some incredibly potent resources for stopping and reversing the ecological crisis that we're seeing.
That's correct.
That is good news. So
is.
Chad Wall, we revere you. We love your work, and we love having found you, and the fact that there's not very many voices out there that are identifying hydration and water use is one of the most underutilized way we're going to recover our whole ecologies. It's just great to have you. Thank you so very much, Chad Wall. I think your website is the name of your website, Chad.
It's natural ecosystem restoration.
Natural
System.
ecosystem restoration.org, right?
.com.
.com. It's very important to know the difference between .org and .com. Thank you so much, Chad.
Yes.
We'll be coming back to you for other interviews, and we appreciate your work.
You bet. Thank you for having me, Gina.
Okay.